Okay, we were in the concave mirrors and we have discussed two cases. Okay, now what are those two cases? So where exactly is the position of the image when the object is at infinity? Then the second case was when the object is beyond C. Okay, those two cases we discussed. Now moving to case 3. When the object is exactly at the center of curvature of the concave mirror. Now you can see here, this is the concave mirror, M dash is the concave mirror, AB is the object. Okay, now this object is exactly at the center of curvature. Now you can see here. Okay, now let us see. When the object is at center of curvature, so from point B, that is the B of the object, an incident ray is made to fall on the reflecting surface of the concave mirror, and this incident ray is parallel to the principal axis. So whenever the incident ray is parallel to the principal axis, the reflected ray should fall on the principal focus. So one reflected ray is coming out and it is passing through the principal focus. One more ray from the same position, that is the point B of the object AB, is incident. Okay, sorry. Yes. Now, one more ray from the point B is incident, or the incident ray is traveling along the principal focus, that is F. So, as per the conventions, sign conventions, whenever a ray of light is incident obliquely and it is passing through the principal focus, the reflected ray is parallel to the principal axis. Now you can see it. Okay, so it is also parallel to the principal axis. What is the reflected ray? Here you can see the reflected ray. So now here you have the reflected ray from point S. Okay, one more reflected ray is coming from point R. That is, you can see here, this is one first reflected ray and this is second reflected ray. Now you can have, or you will get the position of the image. Where is the position of the image now? The image is formed at the center of curvature itself. So what is the conclusion that we have drawn here? When the object is placed at center of curvature, the image is formed at center of curvature. You can see here A dash, B dash is the image. AB is the object. So what are the conclusions? As I told you, when the object is at C, the image is formed at C itself. Then image is real. Yes, of course it is real because it is on the screen and inverted. Most importantly, whatever is the size of the object, the image is also having the same size of the object, which means height of the image is equal to the height of the object, or size of the object is equal to the size of the image. So image is same size as that of object, image is real and inverted, image is formed at center of curvature. So when the object is at center of curvature, image is also formed at center of curvature. Next, case 4. When the object lies between center of curvature and focus. So this is contradictory to the second case. So what was the second case? When the object is beyond C, you are expecting the image between C and F. Now, the object is between C and F. Obviously, the image has to be beyond C. So it is what? The contradictory to the case 2. Okay. Now, when the object is between the center of curvature C and the focus. Now you can see here, there is an image. Sorry, there is an object. When the object is at between center of curvature and focus. Now you can see here, AB is the object and an incident ray is parallel to the principal axis and it strikes at some point and it gets reflected along the principal focus and it travels further. Now, one more ray from the point B is incident at some point. Say I will mark this 2 points as R and S. Now, the first ray coming from B of the object is hitting R along the reflecting surface and it is getting reflected along the principal focus and travels further. Now one more ray from point B is incident at a point S, and this ray is getting reflected back along the same path. Why? Because this ray is travel, or this ray will move passing through the center of curvature. Remember, whenever the ray of light is incident obliquely along the center of curvature, it retraces the same path. Similarly, you can see here, this is the incident ray and this is the reflected ray. Why? Because even though the ray is incident from B, upon reflection, this ray is passing through the center of curvature. So when the ray is passing through the center of curvature, its incident path and the reflected path should be same. So that's why the reflected ray is traveling along the same path, passing through the center of curvature, and it is meeting the first reflected ray. Where is the first reflected ray? That is from R. When it is formed, when both the reflected rays meet at that point, you will get the position of the image. Now you can see here, A dash, B dash is the image. See the object, AB is the object, A dash, B dash is the image. Now you can draw the conclusion. What is that? When the object is placed at center of curvature and the principal focus, the image is formed beyond center of curvature. The image is formed beyond center of curvature and the image is enlarged. You can see an image is enlarged, means very big. Compared to the size of the object, image is bigger image you are getting. So it is opposite to that of case 2, remember, okay? So image is enlarged, okay? And image is formed beyond the center of curvature. Of course, the image is real and inverted because it is a concave mirror. Hope you have understood. Thank you. Okay, students, moving further to case 5. Okay, so now we have when the object is at F means principal focus. When the object is at principal focus, now you can see here, when the object is placed at principal focus, AB is the object, an incident ray from B of the object is incident parallel to the principal axis at some point R along the reflecting surface of the concave mirror. And obviously, when the incident ray is parallel to the principal axis, it gets reflected along the principal focus as per the convention. Now, one more ray is passing through the same position B, that is incident, and at some point S along the reflecting surface, and the reflected ray is tracing the same path. Why? Because the ray is passing through where? The ray is traveling along center of curvature. You can see here. When a ray is incident from point B to S, that is along the reflecting surface, it gets reflected. You can see here. The reflected ray is coming along the same path. It will come to B, and again it is meeting at center of curvature. That's why the reflected ray is tracing the same path, and it is coming along the center of curvature and moving further. Even the reflected ray from R, it is passing through the principal focus and it is moving further, and you are getting the image at infinite distance, very far distance. Remember the first case, right? So now you are getting the image at a larger or image at infinity. Now, of course, that's why I have drawn the dotted lines. Why? Because at infinite position I am expecting the image. So let us see what will be the nature of the image. The image is formed at infinity. Image is enlarged. Opposite to the case 1. There it was diminished, point size. Right? Here the image is enlarged. And the image is of course real and inverted. Okay. Now when the object is at principal focus, the image is formed at infinity, but the image is magnified or enlarged as compared to the size of the object. Okay, and the image is real and inverted. Next is case 6. This is the last case. When the object is between principal focus and pole of the mirror. Very important case this is. When the object is at F, that is principal focus, and the pole of the mirror, you can see AB is the object. Okay, now let us analyze here. Now from the point B, a ray is drawn parallel to the principal axis and it is incident on capital R of the reflecting surface of the concave mirror. Since the incident ray is parallel to the principal axis, it is getting reflected along the principal focus. Now the same ray, at the same position B, one of the rays is incident on the point S along the reflecting surface, and again it is coming along the center of curvature. It is retracing the same path. Now, what is the speciality of placing an object in between principal focus and the pole of the mirror? You should be very obvious that till now whatever we have learned, we have placed the image at focus, beyond the focus, or beyond the center of curvature, at infinity, or at focus. Now the image is little bit within the focus. When the image comes within the focus, what happens? You will not get a real image, you will get a virtual image. Because if you want to get a clear image, okay, whether it is real, means a real and inverted image, either it should come on the focus or beyond the focus, right? But when the object is placed between the principal focus and the pole of the mirror, you can see here the reflected rays which are traveling along the principal focus, it appear to be. So that's why I have drawn the dotted lines behind the mirror. Okay, to the other side of the mirror, I have extended the same reflected ray from R and from S so that it meets a point. From that point, I have drawn a dotted lines of the image. So you can see here A dash, B dash is the image. Now where is the image formed? Image is formed behind the mirror. Image is formed behind the mirror. So whenever an image is formed behind the mirror or far from the mirror, it is a virtual image. So image is virtual. Okay, when the object is between principal focus and the pole of the mirror, image is virtual, which means it is behind the mirror. Now image is enlarged, means image is bigger than the size of the object. Okay, so that is the case 6. So we have studied all the 6 cases. Okay, now let us have a conclusion, okay, or a summary of all these 6 cases. Now you can see here position of the object, position of the image, size of the image, nature of the image. Now see, first, when the object is at infinity, image is at principal focus, image is diminished, image is real and inverted. When the object is beyond the center of curvature, image is formed between center of curvature and principal focus. Image is diminished, small in size. Image is real and inverted. When the object is at center of curvature, object at C, image is also formed at C. Image is of the same size of the object. Image is real and inverted. Now, when the object is between center of curvature and principal focus, object is formed beyond C. Object is enlarged than the image is enlarged than the object, and the image is real and inverted. Now, when the object is at the principal focus, image is formed at infinity. Image is highly enlarged, not only enlarged, it is highly enlarged, and the image is real and inverted. So last case, that's what we have discussed now. When the image is between pole of the mirror and the principal focus. When the object is at the principal pole of the mirror and principal focus, the image is formed behind the mirror. As you can see, the image formed behind the mirror. So it is virtual, right? Image is virtual and erect, means it is erect. but the image is enlarged because you can see the height of the image and the size of the image. It is enlarged. Okay, thank you. Now, till now we have understood and finished learning about concave mirror. Now let us go to convex mirror. So what are convex mirror? Convex mirror, they are the spherical mirrors in which the reflecting surface is away from the center of the curvature or center of the hollow sphere. Okay, now you can see here, whatever the mirror that I have drawn is a convex mirror. Now let us see. Just like concave mirror, we have studied 4 rules. Okay, that is how to trace the images. What are the rules that we have to follow for concave mirror? Similarly, here also there are 4 rules. That is rules for tracing images formed by convex mirrors. Now, be careful while drawing the image formation in a convex mirror. Why? Because in convex mirror, you are getting the image to be virtual. Okay, so virtual means behind the mirror. So, whatever the lines that you are drawing behind the mirror, even the object also, make sure that you are writing in dotted lines so that it will clearly make a difference between the object and the image. Okay. Now, the first rule is a ray of light falling on the mirror in direction parallel to the principal axis of a convex mirror appears to be, I have underlined the word, appears to be coming from its focus. On focus means principal focus on reflection from the mirror. So this is the first rule. Now you can see here. Now this is convex mirror. This is the reflecting surface. Obviously the incident ray should come on the reflecting surface. Okay. Now see, here is the reflecting surface. Now incident ray is coming. And the center line is principal axis. P is the pole of the mirror. To the other side of the mirror. Okay. Or behind the mirror only you should have principal focus and center of curvature, not here. Why? I have told you that the mirror means hollow sphere. So the hollow sphere means you are getting the hollow sphere like this, not here. Okay. So keep that in mind. Now, when the 2 incident rays, that is above the principal axis and below the principal axis, they are coming, and where should be the reflected ray? Now you can see here, this is the reflected ray, first reflected ray and this is second reflected ray. Now, when the incident ray is coming like this, you are getting reflected like this. How? Again, you know, that has to be in a form of certain apparent, what you can say, understandings. How? Now you can see here, this principal focus and center of curvature is behind the mirror. Even though the reflected ray is coming, okay, at the incident ray itself, now you can see here at this side itself, it appears to be coming from principal focus only. So that's why you can see here the dotted lines. Whatever the lines that you are drawing, except the principal axis, the other lines that you are drawing, including the image, you should represent it in dotted line. Now you can see a dotted lines coming from the principal focus and meeting at this point where the incident ray is incident, and from there only extend the line, you will get the reflected ray, which means to say that these 2 reflected ray are appearing to be coming from principal focus. So converse of it means ultimately the rays are meeting the principal focus. So this is the word. That's why you should not forget to write the word appear. If you don't write the word appear, it makes wrong. So appear, that word appear has to be there in the sentence. So that is the first rule. Okay. Now the second rule. The ray of light falling on the convex mirror on passing through the center of curvature of the mirror. Remember here, on passing through the center of curvature of the mirror means it is very clear that it is a convex mirror, and center of curvature and the principal focus, those 2 parameters will come behind the mirror. Okay. Through the center of curvature of the mirror is reflected back along the same path, or it retraces the same path, just like the rules of the concave mirror, but here it is virtual. That's it. Now you can see here, this is a convex mirror. Now the center bold line is the principal axis. To the other side of the mirror, that is behind the mirror, you will find principal focus and center of curvature. Now you can see here, a incident ray is incident obliquely. Okay, obliquely means like this, not parallel to the principal axis. It is incident obliquely, so that when it is incident to the other side of the mirror, means what? Non-reflecting surface will come, right? So to the other side of the mirror, you should represent in dotted lines. Now you can extend this bold line, that is the incident ray, using these dotted lines so that it meets the center of curvature. Again, from here also it is meeting the center of curvature. Remember the sign convention, whenever a ray of light is passing at some oblique incidence along the center of curvature, it retraces the same path. Now you can see here, this is the line of the incident ray, and along the same line you are expecting the reflected ray. You can see here. Both this side of the mirror as well as that side of the mirror I have shown, this is the incident ray and this is the reflected ray. Why? Because they appear to be moving along the or moving through the center of curvature. They appear to be moving through the center of curvature. That's why the reflected ray is tracing the same path. And remember, whatever we are doing here, it is a virtual. Okay, these are all the virtual. Thank you. Now we have finished two rules. Let us go with the rule 3. Okay, that is we are dealing with the convex mirrors. Now what is the rule 3? A ray of light falling on the convex mirror on passing through the focus, of the mirror becomes parallel to the principal axis on reflection. This is nothing but it is reverse of rule 1, right? I repeat, a ray of light falling on the convex mirror on passing through the focus. You know where the focus and the center of curvature, right? Their position you should remember. Whenever you are reading that sentence, you should remember that those are towards the other side of the mirror, that is on the virtual part. On the focus of the mirror becomes parallel to the principal axis on reflection. Now you can see here, this is the convex mirror. The center bold line is the principal axis, and here you have principal focus and center of curvature. Now here you can see the incident ray. Okay, you can see the incident ray, which is incident at some angle. It is not parallel, it is incident at some oblique incidence at these 2 points. And obviously those two rays appear to be though these two incident rays appear to be coming from focus. That's why I have drawn in dotted lines. And the reflected ray should come towards the same side or the same plane where there is incident ray, right? So now you can see here, this is the reflected ray. These two are incident rays, these two are reflected rays. It appears to be coming from principal focus. Why we use the word appear? Why? Because it is convex mirror. Okay. Now these two reflected rays, you can see here, these two reflected rays are parallel to the principal axis. That is, you can see here, it becomes parallel to the principal axis. So this is rule number 3. Now coming to rule number 4. A ray of light incident obliquely towards the pole, directly on the pole of the convex mirror is reflected obliquely. So incident ray is oblique, therefore reflected ray is oblique when only it is incident on pole of the mirror, such that the incident and the reflected rays make equal angles with the principal axis. As simple as that. Now you can see here, this is the convex mirror, this is the principal axis, and here you have principal focus and center of curvature. Now you can see here, this is the incident ray. Okay, now this is the incident ray. It is at some oblique line, okay, or oblique incidence at the pole of the mirror, okay, upon the pole of the mirror, that is the center of the mirror. Now you can see the reflected ray coming out here. So angle I is angle of incidence, angle R is angle of reflection. Both angle of incidence is equal to the angle of reflection. Now you can think, where exactly is the image? Of course the image is formed along the other side of the mirror itself, but we are not concentrating where exactly is the image in these rules. Next we take up the two different cases. Okay, so where we can study the position of the object and position of the image. So this is the rule 4. Thank you. Now, very important, just like how we have learned 4 cases in the image formation by a concave mirror. Here we have only two cases for the image formation by a convex mirror. Now let us go with the case 1. Okay, what is the case 1? When the object is at infinity. So the object is at infinity means very far distance. Okay. Now you can see M dash is the convex mirror. The center line passing through the pole, the principal focus at the center of curvature, that is principal axis. Now you can see here, the object is at infinity, we don't know where is the object. From that object, two parallel rays are coming. You can see here two parallel rays, okay. I shall name this as, say for example, R and S. So RD and SP, RD and SP are the two parallel rays which are coming, and they are meeting at different positions of the reflecting surface of the convex mirror at positions D and one more position, that is the pole of the mirror itself, that is P. Okay, these are the two parallel rays. Now you should have a clear mind or the understanding while writing the ray diagram in the convex mirror. That is, always the image is formed to the other side of the mirror, okay, far behind the mirror. Why? Because it is virtual. Now you can see here the two incident rays are meeting at the point D and P. P is pole of the mirror. Now what you have to do is, at this point D, obviously this incident ray has to be reflected. Now in order to get the reflection, it is assumed that that ray is coming from the principal focus. Now you can see here, from the principal focus you draw a dotted line and that should meet at D. From the D you just extend further, let it be a bold line, okay, extend further. Now this becomes DE is a reflected ray. Now between the incident ray and reflected ray there should be a normal, because it has to obey the law of reflection. Now you can see here, from the center of curvature draw a dotted line or a straight line, okay, CD. Okay, and then extend the D till N so that it is a straight line coming in between the incident ray RD and the reflected ray ED, so that you are getting a normal. So which means that angle of incidence is equal to angle of reflection. Okay, now you have drawn a normal. Why? Because it has to obey the law of reflection. Okay, now you got the reflected ray coming out, okay, at point D. Now one more incident ray is incident on the pole of the mirror. What it has to do? So we have just now learned the fourth case, right? So the fourth rules in the convex mirror. Now whenever a ray which is incident obliquely at the pole of the mirror, okay, it gets reflected. Now this is the reflected ray, but it is assumed to be coming from the other side, right? So what you have to do? Extend this reflected ray back, okay, extend this reflected ray back in such a way that that reflected ray and the ray which is coming from the principal focus, that is ED, okay, that is coming from the F, D and E, this reflected ray which is coming from the principal focus and meeting at D, that is the first ray, okay, and it is extended till D, that ray, that appearing ray coming from the principal focus, as well as the reflected ray which you have extended to the other side of the mirror, both should meet at some point, they will intersect at point. That point is the position of the image, okay, that is the position of the image. You can see here, A dash, B dash is the position of the image. Okay, so I repeat, the reflected ray which is appearing to be the reflected ray DE appear to be coming from principal focus F, and the reflected ray at the pole of the mirror extended to the other side of the mirror, that is behind the mirror. They are meeting at some point, they are intersecting at that point. At that intersecting point you are getting the image A dash, B dash. Now that image is diminished, very small. Okay, that's why you can see here, the object is at infinity is very large, okay, but whatever the image that you are obtaining at this particular position is diminished. Now what is the speciality? You can see here, this image is not inverted. It is erect, which means to say that it is non-inverted. if this is the position of the object, you are getting the image like this only. It is not inverted, it is an erect image. This is the speciality of the convex mirror. Okay. Now, what is the different characteristics of the image? Image formed is at principal focus. Okay, image is formed at now the image is formed at the principal focus. Okay. Now the image is highly diminished image. The image is highly diminished image. You can see here the image is diminished. Why? Because it is very, very small as compared to the object which is at infinity. Now the image is virtual. What do you mean by virtual? The image is virtual means the image is to the other side or far behind the mirror. Okay, and erect, which means it is the orientation is the same. Okay, it means it is non-inverted. Now next is case 2. What is that case 2? When the object is at finite distance from the mirror. So case 2 is when the object is at finite distance from the mirror. What is that finite distance? In a way that it is also called object between the object is at infinity and pole of the mirror. Now see here, this is infinity and this is pole. So infinity and pole, in between you have the object that is AB. Now carefully you can observe here, from the AB, from the position B, a ray which is drawn parallel to the principal axis. You can see the principal axis. Obviously when the ray is drawn parallel to the principal axis, it has to meet the principal focus, but here it is virtual concept. The rays appear to be, the reflected rays appear to be coming from the principal focus to the point D and it is getting reflected. So one more ray you have to draw, okay, that is from the center of curvature as a normal at from C to D and it is extended, that is a normal. So we have an angle of incidence and angle of reflection, obeying the law of reflection. Now one more ray from the same point B is incident at E. So when it is incident at E of the reflecting surface of the convex mirror, since to the other side the virtual concepts will follow, it appears to be coming from center of curvature. You can see here. It appears to so, or in a way saying that that line is meeting the center of curvature or passing along the center of curvature. Whenever a ray of light or incident ray is passing through the center of curvature, it retraces the same path. You can see here. This is the incident ray, it retracing the same path. Okay, this is tracing and this is retracing. While retracing the same path from this ray, it will intersect the 2 points. That is the one ray which is coming out of the principal focus at D and it is coming out as a reflected ray, and the ray which is appearing to be coming from the center of curvature to the point E is intersecting at some point. So at that point you are getting the position of the image, that is A dash B dash. Now A dash B dash is the position of the image. Where it is formed? It is formed in between pole of the mirror and the principal focus. So the image is formed between pole of the mirror and principal focus. So when the object is at infinity, okay, when the object is between infinity and the pole of the mirror, the image is formed between pole of the mirror and principal focus. The image is formed between pole of the mirror and principal focus. So this is the explanation. So what is the characteristics of the image from the case 2? When the object is between the infinity and the pole of the mirror, the image is formed between pole of the mirror and principal focus. The image is diminished, you can see here. So object is large, image is small, so image is diminished. And of course image is virtual and it is erect, you can see here. It is non-inverted or it is erect. Thank you. Now coming to the uses of uses of spherical mirrors. The first you have concave mirrors. So concave mirrors are used in the reflector in torches, headlight of vehicles and searchlight. they are used in shaving or makeup mirror to get the magnified image. We have all seen that. And it is used as doctor's head mirror to focus on the parts or the body parts like ears, eyes and nose. Okay. Coming to the convex mirrors, they are used in reflector in street lamps. And the drivers of the automobiles, that is various trucks, cars, they use these convex mirrors as a rear view mirror. Okay. And even we have seen that. Now coming to the difference between the three types of mirrors what we have discussed, that is plane mirror, concave mirror and convex mirror. In plane mirror, the image is virtual, the image is erect and image is same size as that of the object. In concave mirror, the image is real and inverted. Whereas in convex mirrors, the image formed is virtual and the image is erect. Thank you.